This is a revision session for OCR FP1. The topic is matrices and transformations, and we're looking at January 2010 question 5. So we'll start by reading through the whole question. So in part 1, we're told that the transformation T is represented by the matrix 0, negative 1, 1, 0, and we're asked to give a geometrical description of T. And then in part 2, the transformation T is equivalent to a reflection in the line y equals minus x, followed by another transformation S. And we're asked to give a geometrical description of S and find the matrix that represents S. So if we look at part 1 first of all. So in part 1, as I say, we are told that this matrix T, which is 0, negative 1, 1, 0, that is actually telling us that if the first column is 0, 1, then that tells us that the unit vector 1, 0 maps on to 0, 1. So if we look here, that means that this point and this line, that will now map on to the vector 0, 1. So we might at this stage suspect what's happening, but we'll just check, because the next thing is that the second column of our matrix tells us the image of 0, 1, and it therefore tells us that 0, 1 maps on to negative 1, 0. So that means that this line, this vector, maps on to this vector. So we've got that mapping onto that, and this mapping onto this. So it is a rotation of 90 degrees anti-clockwise about O. So we get 1 mark for saying that it's a rotation. So you get 1 mark there. Just put that in. 1 mark here to just writing that down, and 1 mark for the fact that it's anti-clockwise. So we need a rotation of 90 degrees and anti-clockwise. So if we now just look at the second part of the question, so the second part of the question says the transformation T is equivalent to a reflection in the line y equals minus x, followed by another transformation S. So what I've done here is I've drawn in the line y equals minus x, so that we see that here, and I've taken the unit square. Now, we only looked at these two vectors the last time, but I have just drawn on the unit square. Some of you might find that easier. So if it is reflected in the line y equals minus x, then hopefully you will see that this line has become here, and this line has become here. So we end up with the image of our unit square down here. So this is now the image. But of course that's not quite what happened the last time. So if you remember, the transformation T mapped 1, 0 onto 0, minus 1. Whereas here we've got 1, 0 has been mapped on to 0, negative 1. So what we'll need to do now is to reflect this bit in the x-axis, and it would be over here, which is what we want. And let's just check that that will also work, because of course that means that this, if we're reflecting in the x-axis, will not change, it will remain fixed. And of course we know from part 1 that the image of 0, 1 was negative 1, 0. So in fact what we're looking for is we're looking for S, which is a reflection in the x-axis. And so that means that 1 naught, for a reflection, 1 naught would map onto itself. So that means the first column of our matrix is going to be 1 naught. But 0 1 would map on to 0 negative 1. So the second column of our matrix is going to be 0 negative 1. So a little bit harder to put all that together, but let's just see how the marks actually work. So you do get a mark for looking at the image of either the unit square or two vectors in the line y equals minus x. You then get a method mark or an accuracy mark for seeing that S is a reflection in the x-axis. And then once you've done that, you get a B mark, just a writing down mark for each of those columns, correct. So if I just put that on again, so a method mark for the image in the line y equals minus x, and an accuracy mark for describing the transformation x, and then these 2 marks for the columns. So 4 marks for the second part, 6 marks in total for the question. So don't forget there are plenty more revision videos available on the Further Maths website.